Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Here is Mubashir Riaz, and today we are going to discuss our next topic, angular velocity and angular acceleration of chapter number 5. So let me start with angular velocity. The rate of change of angular displacement is called angular velocity. The rate of change of angular displacement is called angular velocity. In other words, we can say that the angular displacement covered by the body in unit time is also called angular velocity, and it is represented by omega. इसको आप omega से represent करेंगे. For example, here there is an object which is following a circular path of radius r. Here r can also act as the position vector, and its angular velocity would be the long axis of rotation, because we know that angular velocity is also a vector quantity and its direction can also be determined by using राइट हैंड रूल. इसकी डायरेक्शन को भी आप राइट हैंड रूल से फाइंड कर सकते हैं, जिसमें हमें अपने कर्ल फिंगर्स को डायरेक्शन ऑफ रोटेशन में रखना होगा. एंड इन दिस diagram, since object is moving anti-clockwise, so fingers are rotating anti-clockwise, and stretched thumb will represent the direction of angular velocity, which is acting along the axis of rotation. Similarly, there is another example. This object is moving in a circle of radius r, and here v is the tangential velocity, or it is also called the linear velocity, tangential or linear velocity, and it is always acting along the tangent to the circle. इसको tangent to the circle दिखाएंगे, but angular velocity is acting along the axis of rotation. Mathematically, angular velocity is equal to change in angular displacement over the time taken. Change in angular displacement over the time taken. So omega is equal to delta theta over delta t, where delta theta is change in angular displacement, delta t is the time taken, and the unit for angular velocity is radian per second. Radian per second is the unit of angular velocity, whereas other units are degree per second as well as revolution per minute. Here degree per second is the smaller unit, revolution per minute is the larger unit to discuss the angular velocity of an object. Now there are two types of angular velocity. First one is called average angular velocity, and it is equal to the ratio of total change in angular displacement divided by the total time taken. The ratio of total change in angular displacement over total time taken. So omega is equal to delta theta over delta t, where delta theta is change in angular displacement and delta t is the time taken. Second type is instantaneous angular velocity. So the angular velocity of a body at any instant of time. When object is moving in a circle, then rate of change of angular displacement of an object at a particular instant of time is called its instantaneous angular velocity, and mathematically it becomes omega instantaneous equal to this limit delta t approaches to zero. Yani this time interval should be very small. टाइम इंटरवल बहुत कम होना चाहिए. Nearly approaches to zero, not equal to zero. Nearly approaches to zero. So at this instant of time, the rate of change of angular displacement is called its instantaneous angular velocity. Now there is a relationship between linear velocity and angular velocity. V is equal to r omega, where omega is angular velocity, v is the linear velocity, और हमें इसके दरमियान relation prove करना है कि linear velocity और angular velocity how they are related to each other. So to prove this one, let s is equal to r theta, and for very small change delta s becomes equal to r delta theta. Now dividing both sides by delta t, it becomes delta s over delta t equal to r delta theta over delta t. By applying limit delta t tends to 0 on both sides. Limit delta t tends to 0, delta s over delta t is equal to r. Limit delta t tends to 0, delta theta over delta t. And we know that this is the rate of change of linear displacement. And this is the rate of change of angular displacement. And both can be replaced with v and omega respectively. आप इसकी जगह पर instantaneous linear velocity put कर सकते हैं, and this one can be replaced with omega instantaneous. Finally, v is equal to r omega. So this is the relationship between linear velocity and angular velocity. The same expression can also be written in vector form. This is vector form. V is equal to omega cross r. V, which is linear velocity, omega, which is angular velocity, r is position vector. So this cross product is equal to linear velocity. And in diagram, we can express in this way. Here r is the radius, or it is also called the position vector. V, which is linear velocity, it is acting along the tangent, and omega is the angular velocity. So with the help of this mathematical form, we can describe the relation. Omega is always along the axis of rotation, r is the radius of circle, and v is along tangent. Now the second term is angular acceleration. And angular acceleration is the rate of change of angular velocity. The rate of change of angular velocity is called angular acceleration, or the change in angular velocity of a body per unit time is also called angular acceleration, and it is represented by alpha. This is the symbol for angular acceleration, alpha. Its mathematical form is the change in angular velocity per unit time. Suppose the angular velocity of a body changes from omega I to omega f, where omega I is its initial angular velocity, omega f is its final angular velocity, and t is the time taken. So angular acceleration is a change in angular velocity per unit time. Alpha becomes equal to delta omega over delta t, and its unit is radian per second square, and the other units are revolution per minute square and degree per second square. These are the units to measure angular acceleration. The type of angular acceleration, which is called average, is equal to the ratio of total change in angular velocity divided by the total time taken. So alpha is equal to delta omega over delta t, and instantaneous is the angular acceleration of an object at a particular instant of time is called instantaneous angular acceleration. Mathematically, alpha instantaneous is equal to limit delta t approaches to 0, delta omega over delta t. Again, there is a relationship between linear acceleration and angular acceleration. A is equal to r alpha. ये हमें प्रूफ करना है. तो इसको प्रूफ करने के लिए हम जो लास्ट में प्रूफ कर चुके हैं उसकी हेल्प लेंगे. That is v is equal to r omega. For very small change, delta v becomes equal to r delta omega, dividing both sides by delta t. Then it becomes delta v over delta t is equal to r delta omega over delta t. By applying limits, delta t tends to 0 on both sides. So limit delta t tends to 0, delta v over delta t is the rate of change of linear velocity at any instant of time, and it can be replaced with a instantaneous. जबकि इसको आप रिप्लेस कर सकते हो विद अल्फा इंस्टेंटेनियस. इंस्टेंटेनियस एंगुलर acceleration. So A becomes equal to R alpha, and in vector form, A is equal to alpha cross R. This is vector form, and the relationship between linear and angular acceleration. And in the last, there are equations of motion for the angular motion. हमने तीन equations पढ़ी हैं. Vf is equal to Vi plus At, which is called first equation of motion. Other is S equal to Vit plus half At square. And the third equation is 2As equal to Vf square minus Vi square. तो जब आप इनको चैप्टर 3 में पढ़ रहे थे तो वहाँ कुछ रूल्स थे, और उन रूल्स में सबसे पहला पॉइंट ये था कि these equations are applicable only to the straight line motion. कि ये इक्वेशन सिर्फ स्ट्रेट लाइन मोशन पे एप्लीकेबल है. लेकिन अगर एंगुलर मोशन को डिस्कस किया जा रहा है तो फिर हमें इन तमाम इक्वेशंस को इन टर्म्स ऑफ एंगुलर मोशन डिस्कस करना है. सो इक्वेशन 1 बिकम्स ओमेगा एफ इक्वल टू ओमेगा आई प्लस अल्फा टी, यानी वी एफ को ओमेगा एफ के साथ, वी आई को ओमेगा आई के साथ और ए को अल्फा के साथ रिप्लेस कर देना है. इन सेकंड, theta becomes equal to omega it plus half alpha t square, and third equation is 2 alpha theta is equal to vf square minus vi square. So these are three equations of motion in terms of angular motion. Thank you.